Hi everyone. Today we are going to learn about machine learning. What is machine learning? It is nothing but where we are making the computers undergo set of training, after which it is able to build a particular model and also able to predict various things, various inputs, various outputs are predicted by using the source data. It makes sense of the data and also we need not program it directly. So here computers are able to learn and they are able to predict the results from the input which is received. So we know that in today's world, data is the new oil. So we are using data to feed into the computers, that is algorithms, and these algorithms are able to predict the values whenever the values for which we want to know. We know about extrapolation and interpolation, where we are able to find in extrapolation, we are able to find the unknown values by using the known values. So here it is kind of similar. Here we need not program the computers. So in machine learning, there are two types of machine learning. One is supervised machine learning, another is unsupervised machine learning. In a supervised machine learning, you are going to train the data on train the models, that is computer, on certain amount of input data. We know this data can be called as a labeled data, where we know there will be different types of data. And using this, we build a model and we predict the values based on this. The computer got trained on. And there is an unsupervised machine learning, which is an unlabeled data. There's no particular set of values are given to it, and but it will create, it will try to make sense of the data and create some kind of patterns by using this. So we will try to understand what is there in supervised machine learning, what are the details of the supervised. So as I told you, it is a labeled data. So what is the labeled data? You got just like you want to predict what is the price of house based on its number of rooms and square feet and also on the location. So it is a labeling of the data where you got a column where you have got the size of the house in square feet and you got a number of rooms. These two parameters are fed into the algorithm, machine learning algorithm, and this algorithm will predict the price of the house. So we got two things. One is input values called as features and output values and which we can call as target or responses from which. So we will have a set of data values which where we will have a features, inputs and outputs. Here inputs and outputs are used to train the data and the data gets trained up. So after the model has learned or built a model, the model has been built, we can use this model to predict further values where you can take a hypothetical situation where you want to predict the house. So it will just predict the size of the price of the house based on this. For example, you have got a car, you want to predict the size of the car based on the brand, car model, then car registration, and miles driven. So all these are input data and this is output price. We use this data to train our model, and this trained model will be able to predict the price of the car. So in supervised models, supervised machine learning, there are two types of algorithms. This can be further classified into regression and classification. So regression In regression, you got the type of data which is used is continuous type. Just like numbers, there is no what you call it can be 1.5, 1.2, 1.3, 1.05 can take a decimal value or an integer value. There is it is a continuous numerical data. Basically, it will be numerical values will be there, just like the price of the house, delivery time, credit time, all these things will be used. While in a classification type of algorithm, here the output we expect will be just like in the case yes or no. By using the various photos of the cancerous cells, we can predict whether it is a cancerous or malignant, whether it is a cancerous growth or its non-cancerous growth. Yes or no type of outputs we want to know. That is kind of classification. This here we use classification types of algorithms, and in regression there's continuous numerical values. So if we further proceed into regression types, uh, here you can see here we got an historical, you take the historical data, how we want to know how the overall machine learning algorithm will work. So here you got an historical data. The historical data is fed into actually before the data is fed, we need to clean the data. The data is clean. It is then transformed. If there is any values which is non-numerical, it is transformed by using it is transferred into zeros and ones. And after cleaning and removing the missing values in the data, usually we remove the missing values in the data and also replace it with mean values, average values, this median values. So it involves cleaning and also subject matter expert will or expert will suggest you to enter, replace some of the values with closer values. We split this data into two types of data. One is trained data, which will be fed into machine learning algorithm. Then, after feeding into machine learning algorithm, one model is built, and this model is we before deploying into real world scenarios, we need to test the data to know the accuracy of the model. Sometimes model, if you directly deploy the model without knowing the accuracy of the model, it may lead to wrong prediction. So if the model is tested on the data called as test data, which we had not used to train the model. This is a hidden data. It's not being used. Now we just feed the input values and try to know the output values using this model. So this data is fed into the model, and this model will just predict some of the values, and we try to compare the actual values with the predicted values, and using various parameters like R square, that is coefficient of determination, mean squared error, mean absolute square error, various parameters we will use, and in case of classification algorithms, we will use something called a confusion matrix, FN score, precision, sensitivity, so many things we will later learn in this module. So we will come to know the exactness, accuracy of the model. If it is okay, it comes into action, it is deployed in some kind of app in the production. We call it as a production mode, so it is deployed in the real world. So first we will go into try to study one of the basic machine learning model that is called as regression. So regression is a supervised model. Among regression models, there are various kinds of models like uh, regression tree model, forest regression, multilinear regression. So one of the most simplest type of regression model is linear regression. So a regression model can be non-linear also, but we will try to simplify and study first simple regression. So for example, we want to predict number of time required to repair a computer. Let's say if there are single units, the units if the one item is to be replaced in the computer, it will take 23 minutes to repair. If require 2 units to be replaced in a computer, it will require 29 units. If it requires 3, so on, number of units to be replaced, as the number of units to be replaced increases and the time required for repair of the computer also increases. So if you plot a graph of number of units with minutes, you can see there is an increase in the number of minutes with the number of units to be replaced. So mean is the, if you take the average of the time required to repair a computer, we can see it is around between 80 and 100. So this is the mean repair time. So someone asks you how much time is required to repair your computer. By looking at the mean value, you can say about 90 minutes is required to repair a computer. So as a general, by using statistics also, you can tell whether a computer can be repaired, how much time is required. So this is a general sense mean time required to repair the computer. Now, but mathematically, we need to, in a linear regression algorithms, machine learning algorithm, we try to build a model, and this model will be able to predict the values. So y we can call as a target and output is the input. So here x is an independent, y is a subdependent. So we can build a linear regression model, simple linear regression model, which we can see looks like an equation of a straight line. V naught is plus V1 plus into X1 plus error. So here V1 is the bias. You can call it as weights are bias. So and we call E is the error, epsilon is the error. So these are two weights. So E is the error. Creating a linear regression model. By intuition, just we by ourselves can create a model. So if you tell a normal person what is the time required to create just time required to repair a computer, he will tell 97.2. He will just take an average. But the machine learning model, what it does is it tries to create an equation, and it will try to know, it will try to add weights. So 10 is the weight and 12 is the another weight. Let's say 10 is the time required to identify the problem, 12 is the time required to replace the unit. If there are more units, number of units are more, then time required will be more, because the time required, because you want to, more units are to be replaced in the computer, more time is required, so it will increase. If there is another model which will predict, let's say we are initial time required is only 6 minutes, let's 18 minutes is the time required to replace each model. Now, if you try to see here, I have plotted a graph of the basic model, which is average from the red line, and another two types of model, model 1 and model 2. This is the actual repair time. I am trying to fit this line, each model with that of the data. So this model, the red green model, you can see it is able to, it is trying to predict the values. So this is, and another black color line was also trying to predict the values. So these you can see this is the most inaccurate model, and among these two, which is the best model we need to know. So you see, you try to subtract the actual minus predicted. You can see these are the erroneous values are differences between the models. Now you have got models. So how to find which is the most accurate model? Of course, you know model 0, that is only mean it is able to tell. That's the most inaccurate model. So we try to know about the accuracy model. We subtract each individual predicted values with that of the actual values. You can see, and we square them. We subtract the actual values with that of the predicted value and sum them, square them, and sum them all. And this summation of squares of differences between actual and predicted is called as sum of squared errors. So you see our first model, that is the zeroth model, the mean model is got a highest error, of course, not accurate. Then we got a model 1, which has a value of 4993. Another model 2 has a value of 50016. Our model 1 seems to be more accurate compared to the model 2. So this is one of the parameters which shows you accuracy of the model. So we have built the model and we have tried to predict, we have tried to find the accuracy of the model. So how does the machine learning algorithm tries to find the V naught and beta naught and beta 1? So whenever the linear regression model tries to build a model, it needs to predict the two, it needs to actually throw the values beta naught and beta 1. So mathematically, we need to solve this equation and find the beta naught and beta 1, and we try to fit a straight line along the data. So this is our actual, this is the predicted value, this is the actual value. Our mathematical equation, to find out beta naught and beta 1, we have to solve the equation in such a way that it should be the difference between actual and predicted should be minimum. So how we are going to solve this? Uh, we are going to differentiate the yi minus the model equation. That is, this equation y of predicted is equal to beta naught plus beta 1 into xi. This is the equation. So this equation, we will subtract the actual value with the predicted value, substitute this equation beta naught plus beta b naught plus b1 into xi in this value, in this equation. So you subtract these two values. So yi minus naught minus bi into b1 into xi. So we square them. So if you differentiate with respect to this, we can find the b1 value. So we are trying to fit the mod. We are trying to solve this equation and find the values of beta naught and beta 1. So similarly, differentiating with respect to beta naught, we get the beta naught. So next is R square. R square is the sum of square regression by sum of square total. So what is sum of square regression is? It is the difference between each individual value which you got output value minus the mean value. This is something we can call it as a baseline model. It is the base model. It is the base model of the linear regression. So then this is the each individual value minus the predicted value. So if you subtract this, square this, sum this, then you get the sum of square regression, sum of square total. So this is sum of square. Total is the difference between the predicted value and the individual value. This is the difference between the mean and the actual. So total is sum of square total is equal to sum of square regression plus sum of square errors. So model, we can represent your weights into x in plus d and parameters wb, and we can call this as a cost function. Our aim is to reduce the cost function f of w comma d and xi minus yi. So thank you. We will continue our next class later on.